In this video, we are asked to write an NPAT formula or a y equals mx plus b formula, and we're also asked to create a graph. We're told that the data shows the drug plasma concentration of fluoxetine, a med used to treat depression and obsessive compulsive disorder. And so as I look at the change values, the first thing I notice is that change I know to be y2 minus y1, and these turn out to be constant. And because they are constant, that means that it is linear. And so I should be writing the y equals mx plus b model, and when I create my graph, it should be that of a straight line. So in the y equals mx plus b model, it is very tempting to plug in the values that we have in the chart. So the temptation, but not the right answer. Temptation is to write y equals negative 0.8x plus 20. And the error here is that this is change in y, using delta for change in y, which is not slope. So the work that I actually have to do is to find slope. So we know slope is y2 minus y1 over x2 minus x1. And so the value for y2 minus y1 is a negative 0.8. And I can see that if I take 19.2 minus 20. And then the value for the change in the x values would be 4 minus 0. So this gives me negative 0.8 over 4, which is negative 0.2. So I have to go back and write an actual equation for this. Y equals negative 0.2x plus 20. And that 20 is the starting amount because here in my data I had the milligrams when time was 0. So I did have the true start for this. When I look at the y ratios, even though we didn't need them at all, the thing I notice is that they are not constant. They are actually really close to constant. So we have 0.96, 0.958, which could be rounded to 0.96, and 0.956, which again could be rounded to 0.96. But they distinctively are getting smaller. So there is an actual pattern to them. And so 0.96, this one at the third digit being 8 is closer than the last one where the third digit is 6. And so we, even though they're close, we want to declare them as not constant. And in general, I would do the change values first, see that it's linear, and not even bother doing the y ratios, unless, of course, my instructor told me I had to. Now, we are supposed to create a graph, so we want to go to our graphing calculator to do that. We want to enter the data, and then we also want to enter our equation, and we want to see that that all matches up. So I start in stat, I hit enter to edit, I go up to the list name and hit clear to remove the previous data that I had, and then I will type in my data. So my hours were 0, 4, 8, and 12, and then my milligram numbers were 20, 19.2, 18.4, and 17.6. Next, I need to think about a good window. So in the x direction, 0 to 13 would give me a little room, or 0 to 15. In the y direction, my highest one is 20, so I'm going to go a little above that, so I'm going to go 25. I'm actually going to go to 0 just so I see my axis. So window, 0, data went to 12, so I'm going to go 15 to give some room. And y direction, I said I was going to go down to 0. My biggest number was 20, so I'm going to go up to 25 to give some room. Going in my y equals, I see my plot is turned on because plot 1 is in the darkened box. And I'm going to type in my equation that we found, and this gives me a beautiful double check because it should hit my data points. So when we had done slope, we found negative 0.2x plus 20 to be the equation for this data. And so I hit graph. Oh, perfect. I see my lines. I see them having that negative slope going downhill, and I see them go right through each of my points. So everything matches up there. We did great. We have a good visual, no concavity. We just have a line.